Hi everyone, this is three problems on graphing log functions and exponential functions, which are inverses of each other. So the first problem we have is a log function, and I have to graph it. Now, if you have a calculator, you could graph it that way, and then it's very easy. I'm going to do this without a calculator. So the first thing I'm going to do without a calculator is just rewrite this in exponential form. And we know that this would be 4 to the x equals y based on our conversion formula. So when I look at this, what I'm going to do is make a table for this. So the table, I'm going to do x, y, and I'm going to use -1, 0, and 1. And when I plug this in, -1 is going to go to 1/4. 0 is going to map to 1, and 1 is going to map to 4. Alright? Now to do the inverse, all we're going to do is switch the x and the y. Okay? So when I switch the x and the y, I'm going to get the log. So when I switch the x and the y, I'm just going to switch the x and the y, and I get 1/4, -1, 1, 0, and 4, 1. Okay, so that would be based on this part. So my new table is x, y, and I would plot this just for the basic. Then after that, we're going to transform this. Okay, the first thing I'm going to do is to, this is -3 times this. This is a shift to the right by 2 units. So since I'm shifting it to the right, I'm adding 2 to my x. So it's -1/4 plus 2, 1 plus 2, and 4 plus 2. I keep my y the same. Okay? Now the last table, what I'm going to do is multiply this by -3. And this is your y, because we could write this as y. So I'm going to multiply my y by -3 and clean up my x. 2 minus 1/4 is 1 3/4. And then we have 3 and 6. And I'm going to multiply -1 by -3, and I get 3. 3 times 0 is 0. And -3 times 1 is -3. And before we graph this, we should already know what the parent function looks like. And so we can graph from there. So basically, I think I already graphed the basic function here. This is this table here. Now we're shifting everything to the right by 2. So all I'm doing is moving these points over by 2. So I will take a color. I'm moving this point over by 2, this by 2, and this point by 2. That's 1, 2. This is 1, 2. And so it's something like this. So what happened is my x-intercept changed. Okay? Now, the next thing we're doing is, is multiplying my y by 3. So when I plot this, I'm going to keep my same x, but my y changes to 3, 0, -3. So here's my x, and instead of right here on the blue, we're at the blue now. So before we were at -1, and now we're at 3. So we go 1, 2, 3. This is, here we go up 1, 2, 3. No, we're still here at 0. And then at 6, we're at negative 3. So I'm back at 6, I go to negative 3. So it shifts down this way. Okay. Now basically, let's see if I'm going to graph this. Our x-intercept stays the same. So when you have the x-intercept, that was at 0, 3. 3, 0. All right. Our vertical asymptote when we first started was x equals 0, but we shifted over by 2. So now it's basically x equals 2. And if x equals 2, then I actually drew this kind of, so you have your shift here, and this should go up this way. So the green one is your graph. Okay? All right. Probably easier to do with the calculator. Next, we have to graph this function. It's a little easier. It's already in exponential form. So what I'm going to do is just graph y equals 4 to the x. It's kind of what we had before. And this is going to be negative 1, 0, 1. So I'm going to get 1/4, 1, and 4. Now, the next thing I'm going to do is multiply this part by 1/2. So when I do that, I have, I keep my x the same, and I multiply my 1/4 by 1/2. I get 1/8, 1/2, and 2. And then the next table is we're shifting down by 3. So I keep my x the same and shift down by 3. So that's going to be 1/8 minus 3, 1/2 minus 3, and 2 minus 3, which gives you negative 2 7/8, gives you negative 2 1/2, and negative 1. So if we look at this, and we graph it, we're shifting down by 3. So I had a horizontal asymptote originally at y equals 0. Now I have a horizontal asymptote at y equals negative 3 because it's a vertical shift down. My intercept is at 0, negative 2.5, which is about here. And I have, let's see what I have here. 1 goes to negative 1. And 2, what would 2 go to? Let's see. And then so it's going to go up like this. Now to find the x-intercept here, what we're going to do is set y equals 0. So when y is 0, what's x? So we're looking for this point here. So we're going to let 0 equals 1/2 times 4 to the x minus 3. I add 3 to both sides. And then I'm going to multiply both sides by 2. I'm solving for x. So I get 6 equals 4 to the x. I'm going to take the logs of both sides. So I take log of 6 equals log of 4 to the x. I'm going to go ahead and move down here. Now I'm going to use my power property and bring the x down here. So I get log of 6 over log of 4. and that's going to equal your x. Okay, I'm going to go ahead and move it down here. So use the power property, you can move the x in front. And then all we're doing is dividing both sides by log of 4. This is base 10 in this case. And then I went ahead and used the calculator, and this number here is 1.29. So when y is 0, this point here, x is 1.29. All right? The last problem is just find the inverse of this exponential function. So the first thing I'm going to do is set this to y. I'm going to interchange the x and the y. I'm going to move over a little. And then just solve for y. So I subtract 1 from both sides. All right. I'm going to multiply both sides by 2. So it gets rid of this. You get 2x minus 2 equals e to the 3y. Since I'm dealing with e, I'm going to take the natural log of both sides. So ln of 2x minus 2 equals ln of e to the 3y. I'm going to use my power property, move it out in front here, so I get ln of 2x minus 2 equals 3y times ln of e. We should know that ln of e equals 1, so 3y times 1 is just 3y. Then I'm going to divide both sides by 3. So we get ln of 2x minus 2 over 3 equals y. And that's all. Have a nice day. Bye-bye.